Today we are going to learn about half-wave rectifier. What is rectifier? Rectifier is current-based device of electronics. So what happened in rectifier? It is rectification of the current. It means the rectifier is a circuit by which AC is converted into DC. Okay? AC means alternative current and DC means direct current. So alternative current will convert into the direct current. So from this application we use half wave rectifier. There is also full wave rectifier, but today we are going to learn half wave rectifier. Okay, this half wave rectifier is based on junction diode. Of course, you know the junction diode, which is PN junction, and you know that the P type semiconductor connect with the plus terminal, means positive terminal, and N type semiconductor which is connect to the negative terminal, then it is forward bias and current can flow easily and properly also, you know that. Now in a reverse bias there are positive P type semiconductor connect with the negative and N type semiconductor connect to the positive terminal. That is called reverse bias, and in this reverse bias current cannot flow properly. Okay, this is minor current flow. Okay, so you know this junction diode as a rectifier. We will see how we use the rectifier with the base of the junction diode. Before we understand that, let's understand first what is AC. AC means alternative current. Okay, alternative current means what? The polarity of the terminal is going to change. It means the positive terminal and negative terminal, there are two terminals. The direction of current is going to change periodically. Okay, so it is change moment by moment. So it is start with 0 to maximum, then decrease to 0. Here we are consider 0 to maximum and then 0. Here is not we are consider negative waveform. Here is only positive waveform because this is half wave rectifier, not a full wave rectifier. That's why is positive waves only, not negative waves. We will see also about the negative waves in full wave rectifier and bridge rectifier in next lecture. So you get a question, what is half wave rectifier? You know that AC current is changing the polarity periodically. Okay, so and you also know that the forward bias and reverse bias of PN junction diode. Okay, so base of the AC current and base of the PN junction diode. Okay, the half wave rectifier can get by this. In forward bias we get the current, in reverse bias with change the polarity. Okay, we cannot get current in reverse bias. Of course, it's change the polarity, then in forward bias we get the current in positive side. Okay, so in reverse bias we are not getting any waveform, but in forward bias we are getting the waveform. Okay, so 0 to maximum, then again decrease. In reverse bias is nothing we get. Okay, again 0 to maximum, again decrease, which is changing the direction periodically in AC current. So let's see the rectifier. This is the half wave rectifier circuit diagram and this is the waveform of the rectifier. Okay, so here you can see this is the transformer. Why we use the transformer in this half wave rectifier? Okay, so let's see first what is transformer. Transformer is device that changing both current and voltage. Changing both current and voltage means what? It is either increase or either decrease. You know that the Ohm's law, when voltage increase, current is decrease, as well as voltage decrease, current increase. So this is the function of transformer in AC power source. Okay, as you can see, there is two coil. There is number of coil. One coil connect with the source, power source, and another connect with the circuit. Okay, okay. Now see, when current fluctuated in the first coil, create magnetic field, okay, and induce the current to the second coil, okay, according to the Faraday's law. This current can be increased and decreased with the base of number of coil, the primary and the secondary coil. There are using step up transformer and step down transformer. Okay, what happen in step up transformer? There is increase the voltage at the output side, and step down transformer there is reduce the voltage in output side. Here you can see this figure, number of coil in the primary side which is more with respect to the secondary side. Okay, so more to less, so it is called step down transformer. Okay, so this is step down transformer, this is primary and this is secondary, and this is the symbol of current, AC current. Okay, instead of this all figure, if you see in circuit diagram only this symbol, you should understand this is the whole diagram is inside. Okay, you should understand there is transformer already used in this circuit. Okay, now see what happening. N1 means primary coil, there are number of coil. So number of coil means high voltage. High voltage means low current. Of course you know in the base of the Ohm's law. And in secondary side there is a few turns of coil. So there is low voltage but high current. Okay, so there's a single phase transformer. Of course there is single phase means unified waveform. There is we only get one waveform. There is no another waveform start with here. There is no another waveform start with here. There is only we get single waveform. That's why it's called single phase transformer. Okay, and there is only two coil. If there is three phase transformer, there is three coil and we get three waveform, not only one. Okay, so let's see the half wave rectifier. Here is input supply is 230 volt AC. Okay, this is AC. Now what happened? You know that AC is periodically changing the polarity. So when A is plus, after apply the source, we get the 230 volt, and AC apply from the primary coil to the secondary coil. AC when A is positive with respect to the B which is negative. Okay, so what happened? Diode is forward bias. Of course is positive, then it is forward bias. So current will flow. Okay, so current will flow, then apply the input this, we get waveform like this. Okay, now after changing periodically, A is become negative with respect to the B. So A become negative and B become positive. So diode become a reverse bias. Of course you know reverse bias current cannot flow properly. So there is no current of waveform. Of course now changing again, A is positive and B is negative. Okay, so again this diode become in forward bias. So we get this. Okay, so this is forward bias, reverse bias, forward bias, reverse bias. So this is waveform of half wave rectifier. We get only half wave from this rectifier, that's why it's called half wave. Okay, we are not getting negative half cycle from the input. Okay, So this is half-wave rectifier. Why it's called DC? Because we constantly get like this output, okay, in the waveform. So this is constant current. There is no changing polarity. Here is only positive, not in negative. Okay, so no changing polarity. It is constant waveform. Okay, so it's called DC current. Okay, I hope you understand the concept of rectifier, which is half-wave rectifier. Thank you for watching.